here we see some dots. And if we just count the number of dots, here I've got six dots. And here I've got 12 dots. And here it looks like I've got 24 dots. So it looks like what's happening is we are doubling. From 6 to 12, we're multiplying by 2. And from 12 to 24, we are multiplying by 2. So our recursive equation, to find the nth term, we'll take the n minus 1th term, the term right before it, and we'll multiply by 2. And of course, with every recursive equation, we want to give a starting value. Our starting value here is f of 1, the day 1, is equal to 6. We've got 6 dots there. For our explicit equation, we can often find that by looking at our table of values, n and f of n. Well, day 1 we had 6, day 2 we had 12, and day 3 we had 24, and so on. And if we write this 12 as 6 times 2, which is where it came from, and the 24 as that 6 times 2 times another 2, okay, and we see that that pattern will continue. We can write this in a condensed form. The 2's are repeating, so we can write that using an exponent, because repeated multiplication is an exponent. So I'm multiplying by 2 twice, and here I'm multiplying by 2 once. And here I'm actually not multiplying by 2 at all, which is 2 to the 0. So we can see that pattern that for the nth term, we have 6 and then times 2 raised to a number that is changing here. That number is always 1 less than n, or in other words, n minus 1. So our explicit function, f of n, is that expression, 6 times 2 to the n minus 1. So now to graph this, I'm going to go ahead and I'll go by maybe tens here. So that will be 10, 20, 30, 40, 50, and then over here 1, 2, 3, and 4. So on day 1 we had 6, which is right around there. Day 2 we had 12, right around there. Day 3, 24. And day 4 would then be double that, which is 48. So up there.